All right, well, let's
So
look at this. So I've written some code starting out. Um, and one of the first things, so actually, oh yeah, I did load tidycensus here. So let me run that. Um, One of the first things is the that I always struggle with is figuring out how to find variables. That's like a huge thing, and it'll be a little bit less complicated here when we're working with the decennial census, but especially if you're working with the ACS, there are so many different variables. Um, and so you've provided a function, and
yeah,
actually, let me just bring up the help file for it, called load variables. And just to be explicit, I'm just going to add the arguments. So let me run this and let's talk about, or why don't you talk about actually kind of what load variables does?
at a basic level, to get any of these tidy census functions to work, and we'll talk through the two core functions in the package in just a moment. But you need two things. You need to know the geography at which you're requesting data. As I mentioned, there are lots of different geographies at which you can request data. You can get states, you can get counties or county equivalents. You can go all the way down in the decennial census, at least to the census block, which in a city is going to be analogous to an actual city block. And so you need that. And I have documentation on the Tidy Census website and in my book as well that shows how to format those different geographies. So we have, once you've figured out the geography, you need to know the census variable. And frankly, this is the hardest part of using the package based on feedback that I've gotten. And there's a reason why I haven't abstracted this or automated it more than I have. And and I'll explain why in just a moment. So the load variables command, the census maintains kind of code books for all of its variables. And in some data sets, you'll have a few hundred variables. In some data sets, you'll have tens of thousands of variables to wade through. What load variables does is it communicates with the census website and then brings in that variable's codebook and formats it in a way that you can browse interactively in R. And so in this case, with load variables, you need to specify a year and specify a data set. So year equals 2020. If we want decennial census variables, that is intuitive. The data set name of PL is a little less intuitive. You'll want to look at the documentation or my book to get more information on how to format this. But data set equals PL means you're looking in the PL data set, which is the PL 94-171 redistricting data, which is the census data that is congressionally mandated that they need to do redistricting. And that is the only 2020 census data that we have right now. So if you run that code, which you have, what I recommend then doing is bringing up the data set in your RStudio viewer. You get an interactive browsable table that has the columns name, label, and concept. And then for some data sets, you'll have a fourth column, geography, that tells you the smallest geography at which the data are available. For the decennial census, all of these variables are available down to the census block level. So the geography column is not needed. The name column is going to be your census variable ID. That's what you're going to need to know to make a request to the census website. The label column shows what the variable means. And so you can expand the column or hover your cursor over any of the cells to read specifically kind of what it is. And you'll see that it gets fairly voluminous. And you have parent columns and child columns as well, where census will kind of break down different tabulations into smaller groups. The concept column then tells you the general topic. And we frequently refer to these as a table in census terminology, which are an organized collections of variables that are related to one another. So table P1, all of the variables in table P1 are in that race concept. That's going to be race and ethnicity broken down a variety of different ways. Table P2 is race by Hispanic origin. So in the US Census, Hispanic or Latino is characterized as an ethnicity, which is considered separate from race. They've considered changing that, but they haven't changed it yet. So this is, again, I've said that I tried to design Tidy Census to remove some of the tedium of working with census data. And frankly, this is a tedious process to go through. But I think it's an important one because there's only so much I think that software should do to automate away what decisions that an analyst is making. And this really, when you're going through this process, you start to get a feel for how the census breaks down its data and how to make appropriate decisions. You know, I've gotten a variety of inquiries from journalists, for example, after the 2020 census came out. And they look at, so if you see on the screen right there, the variable P2 underscore 006N. It says total not Hispanic or Latino, population of one race, Black or African American alone. The data, David, if you scroll up toward the top, you'll see that there's also P1 underscore 004N, which shows population of one race, Black or African American alone. And so journalists, I've gotten a few journalists who contacted me and they've said, what's the difference? You know, which one should I use? I'm interested in reporting on the Black population in my city. What should I use? And so what you see here is it's easy to get confused if you just go in and say, I want to know uh, about the geography of the Black population in my city. I look at the very first variable, I say that's the one that I grab. But demographers will say, no, that's not the one you should look at. Because typically when we talk about race in American cities, we separate out Black or African American from Hispanic or Latino. And so this variable we're looking at includes people who have self-identify as both Hispanic and Latino or not Hispanic and Latino, but also identify as Black. So if you identify as Black and you're, say, from the Dominican Republic, you're also identifying as Hispanic. That is maybe tangibly different as, you know, someone who identifies as Black and whose ancestors were from, let's say, you know, second generation Nigerians who have moved to the US or who have sort of generational roots in the US. Those are the types of sociological questions I think that census data analysts should be thinking about when they're representing data. How
Yeah,
census
that's good. I
separates
think
that
it's a
out.
really good point that, you know, you can automate the process of looking at the variables, but understanding what the variables mean is an entirely separate question. In particular, you know, this example of race versus ethnicity gets complicated for the reasons that you specify. So it's a I think a really good reminder that it's not as simple as just writing some code. You really do have to be considering what you're actually doing.
Absolutely. So as a follow-on to that, you don't have to scroll through everything. There are a little filter. There's a filter button and there's a search
So
box
for
in
example,
that variables viewer in our studio that allows you to, like, let's say you put in exactly African into the search box, you're already down to
Mhm.
23 out of the
Yeah,
328 variables. And this is now much easier to parse.
cool. And just to show, um, so for example, this load variables. So if I copy this, I did that for, actually, let me just copy this whole thing. If I wanted to get, like ACS, um, let's say I wanted to get ACS 2019 variables, I could just easily adapt this code. And all I have to do then, and I'm
Mhm.
actually looking at your documentation, is um, just do that, right? Have I written that correctly? I think I have. And so this takes a little
You
longer,
have,
right?
yeah. So go ahead and run it. It'll take, well, you're pulling in now 26,000 variables instead of 300 or 27,000. But
That
we
was
have
a lot
substantially
faster.
sped up the
Yeah.
parsing over the years. So it's pretty quick now. It
Okay.
used to be really slow. And so
Yeah.
that's an improvement we made. So David, go ahead and open that one up. And you can see
I see.
that there's, I mean, there are a lot, but notice the geography column. So this is something that we just added this year. You'll see that geography column will tell you the smallest geography at which a given variable is available. So all of those sex by age variables, you can go down to the block group level. But if you scroll down a little bit more, you'll notice that when we have that separated out by race, it's only going down to the tract level. And the reason why, for those of you who might be new to census data, the reason why census does that is that the ACS is based on a survey sample. And so it's characterized by uncertainty. And we can talk about this a little bit more in a moment. But if you have a smaller group, the further down you go, the smaller geography that you go to, the estimates become less and less reliable.
One thing that's really nice as well about Tidy Census is you have a really great documentation. And so when I started using it, I wasn't super familiar with all the different geographies that you could use. And so you actually, talk about all of them and show which, well, we're going to get into get ACS and get decennial, which functions you can use them with. But for example, how you were explaining that some of them you can only use down to the tract level. This actually helps you to understand that block group is more granular than census tract. And so that's why like you said, you can only get it down to that level. But the documentation on the Tidy Census website will really help people to understand that. Cool. All right. So
Thank
once
you.
you figure out what the data is that you want to get, there are, like I said, a couple functions that you're typically going to use: get decennial or get ACS. So I've written some sample code that uses get decennial. Um, so let me actually again just open up the help file before I run this code. Um, so one thing I've always noticed is that get decennial actually has a lot of uh, arguments, most of which, to be honest, I never touch.
It does.
So what are the kind of required arguments and well, we can just leave aside for now at least the ones that you don't have to touch. So which are the required arguments when you're using get decennial or get ACS?
The only required arguments are geography and either variables or table. Other than that, everything else is unnecessary, depending on the data that you want. Now, you might want to be specific about it because a point of confusion sometimes for new users is that you don't necessarily have consistency across some of these arguments across years. So going back to so Tidy Census pulls from the 2000 decennial census, the 2010 decennial census, and the 2020 decennial census. Anything older than that, you should look at the University of Minnesota's NHGIS. They go all the way back to 1790, which is incredible. So in Tidy Census, we have access to census data since 2000, and the default year is 2010 and will remain so until when the full 2020 census data are released. So you need to specify a geography. That's going to be your level of aggregation. You need to specify one or more variables. So if you're requesting more than one variable, you'll specify that as a vector of variables. The year is going to be important because variable IDs change from year to year because the census has evolved quite a bit over the years. So in 2000, this was before the American Community Survey. And so instead of the American Community Survey, what Census did was they sent out one form to the entire US population, and then they sent out a second form to 1 in every 6 households. The second form, which was called the long form, had all of the different socio-demographic characteristics that are now in the ACS. And so the core demographics in 2000 are found in summary file 1, which is, you see the sum file argument, the default is SF1. Whereas the more detailed demographics in 2000 were in summary file 3, which is specified as SF3. Well, summary file 3 didn't exist as of 2010. So instead, it was replaced by the American Community Survey. And so um, that is one change that happened. And by 2020, we've gotten rid of SF1 and SF3 entirely. We're going to have a whole new data set coming out next year. Right now, the summary file that you need is for 2020 data is sum file equals PL. I try to,
Hmm.
you'll notice that's kind of confusing, and understandably so. And I try to abstract that away as best as I can. So right now, if you put in year equals 2020, Get Decennial knows that you need sum file equals PL, and it just does that for you. So it tries
Yeah,
to be intelligent about that depending on what the user needs so that you can
cool.
get
Well, let
data
me
with
go
as
ahead
few
and run
arguments as
this,
possible.
and so I'm not saving it. Actually, let me save it. Call this Tino 2020. So if I open this up now, um, talk me through the output that get and what the different variables refer to. Some of them are obvious, some of maybe a little bit less so.
So this is one area where tidycensus really reflects my opinions about how data should be returned. And you'll especially see that when we look at ACS data. So by default, there are 4 columns that come back from a default call to get decennial. GeoID, which is going to be your census ID code. Uh, this is sometimes referred to as the FIPS code, but um, it's going to be a character column that's composed of numbers that uniquely identify that specific geography. So Alabama's code is 01, Alaska's code is 02, and so on and so forth. The name column is also returned by default because not many people know what their location's GeoID is. Name is more intuitive. So that'll give you kind of the commonly understood name of that specific place, Alabama, Alaska, etc. Variable is going to be your census ID by default. So we asked for variable P2 underscore 002N. It's telling us that's what's represented in this row. And then the value column is going to be your data. So in this case, that is the total Hispanic or Latino population in that state. So something that Tidy Census users should be aware of, however, you'll see in the help documentation, the argument output equals tidy, which gives you long form data. Some analysts don't like that, and they prefer wide form data where each variable is in its own column. And so you can specify the argument output equals wide, and that's going to spread variables across the columns.
So, okay. So you mentioned before that you can get multiple variables. My code up here just got that one variable p2 underscore 002n, but I added another one here. So just to show people, if I do that, what I get is geoid name variable. Now it's not obvious that there are multiple here because it's they're hidden. But if I pop up here into the viewer, you can see I start out with P2001N, and then as I get down, P2002N.
Yes. So it stacks them. So in this case, you'll have multiple rows per geographic unit. So Oregon's going to have 2 rows, one for each variable. And this is what we call tidy or long form data, where the most refined unit in the data set is not the geographic unit, but the unit variable combination. And this is a format that works pretty great
Yep.
for tidyverse visualization and wrangling. If you're doing, say, a group by and a summarize, you can group by variable and then summarize on value pretty readily. But frankly, this is something, and this is feedback I've gotten. And again, this is why tidy census kind of reflects my own opinionated approach to data analysis. Some analysts prefer that the different census variables have their own columns. And that's actually how the data come back by default
Yeah, and so
from
I can
the
even
Census
add, so
API.
output, so I took the same exact code, all I'm changing is that output equals wide, and so exactly now we can see those different variables each have their own column now.
Yeah. Yeah. And so this is, if you're coming, in many cases, if you're coming from a GIS or a spreadsheet background, this is how you're typically accustomed to working with census data. And,
Yep,
it's not, you don't have to use pivot wider or tidy or one of
yep,
their functions to do that. Like, it provides that for you out of the box if you prefer that. And David, the one thing I should mention as well, so we talked about the way that tidy census works, and it's assembling all those arguments, bundling them into basically a URL query string that it sends to the census website, gets the result back, cleans it up, gives it back to you. The one thing that any new users will need to do is get an API key from the Census Bureau, which you only have to do once. Um, if you just Google Census API key, it'll be the first hit. Put in an email. That's all you need to do. There's a little information up there on the screen about it. And then you can install the key with the function census API key in tidy census. Once you've done that, what it'll do is it'll write your census API key to your .environ file. If you haven't heard of that before, it's something that is nice to know about, but frankly, you don't have to worry about it too much. It just kind of think about your key is in your registry,
yeah.
R knows to look for it,
And yeah,
and you
that's a
can
good
go
point. We
on and not
didn't
have to worry
mention
about
that.
it.
The nice thing is, as
So
opposed to other API keys, I remember this one actually comes really quickly. You basically email, or not email, you fill out the form and then
it
they email
does.
it to
Yeah.
you. I think it was almost right away, which is nice. But yeah, you do have to have that set up, and obviously I've done that, so it is set up. Cool. So looking at this, and let me go back to this where we were actually getting that data in that tidy format. The problem that when I work with census data, and I think a lot of people have, is like you don't want to have to remember, okay, what the heck is P2 underscore 002. So one nice thing is you set it up so that you can provide this syntax on line 85 here, where you can actually name or give a nicer name to the variable. So for example, if I run this, now instead of P2 underscore 002N, we can see Hispanic Latino population, which is helpful. And of course, you could do that. I mean, um,
Yeah. Yeah.
here, for example, after I run that, I could do like a mutate case when or a recode or something like that. But being able to do that within um,
Mhm.
the functions that you provide is really helpful. Um,
And you can
oh,
thank the user
interesting.
community for that feature. So when I first released tidy census, you couldn't do that. And I had an early,
Yeah.
early issue filed by someone who said, it would be great if you could do that. And I
Uh,
replied with, no, it's easy enough to do that otherwise. And then I thought about it for about a week and I thought, you know what? I was wrong and this user was right. Uh, you should be able to do that.
All right, cool. So we can name our variables, which can be helpful. Um, let me show now. I was thinking, okay, like let's come up with some way to actually use this and actually calculate something. Like all we've done so far is just pull in that data directly. But the nice thing is because it comes, like you said, in that tidy format, it allows us then to take that data and create kind of a larger pipeline that we can do things with. So for
Hmm.
example, I was thinking like, what if we could calculate the percentage of the population in each state that is Hispanic or Latino? And actually, though, before I even get to that, let me just one thing really quick that I thought might be interesting is we've done everything at the state level just to
Sure.
show folks kind of how easy it is. Like I could change this to county,
Yeah.
and if I rerun that, it now shows me for all 3,000 plus
Hmm.
counties in the US, the Hispanic Latino population, which is incredible. I mean, I literally just changed, a few characters and I'm getting
Yeah.
all that new data, which now that I work in tidycensus just seems like the smallest thing. But again, if we think back to how I was working before and how you were working before, that would involve, if you're not working in R, if you're not automating it with tidycensus, that involves going to the Census Bureau website, finding the right file, downloading that file, and then starting to work with
Yep.
it. Instead, we can just change one little thing, which is incredible.
Yeah. And even if you're experienced at that, that's still 30 minutes of your day because there is just a physical amount of time that's required to visit the website, navigate through the menus,
Right.
download the zip CSV, open it, and then read it in.
Yep.
And that's something that this abstracts away with
Let me go back
APIs.
now and think about like actually, calculating something. So I was thinking it would be nice to be able to um, calculate, for example,
Sure.
percentage of Hispanic Latino folks in each state or county. And so, when I got this here,
Hmm.
obviously that only has, and let me just change it back to state for simplicity. That only has the total Hispanic Latino population. So if we're going to calculate the percentage, obviously we're going to need to know the non-Hispanic Latino population.
Right.
And if I were working with this, I could just go and look and find, okay,
Yeah.
here is that not Hispanic Latino. Okay, that's P2003N. And I could that same thing. And I've done that syntax where I can name my variables. So let me actually just run that. Wait, you can't actually see it.
Hmm.
So you can see now for my variables, I've got Hispanic Latino population for some of them and not Hispanic Latino population. And if I sort by name, which is the state name, you can see. Okay. Cool. So what I did then
Yeah.
was I wanted to, get the percent of the Hispanic Latino population. So basically this divided by sum of these two for each state. So just some simple tidyverse code, group by, or this is dplyr specifically. A group by, and then I calculate PCT as value divided
Yeah.
by sum of values. So in other words, this divided by the sum of these two. And then I ungroup. Let me actually show it there. And actually for simplicity, let me just arrange by that. So see. So I can see, for example, now Alabama, Hispanic Latino population is 0.5 something, so about 5%. Uh, um, and
Yeah.
then I was thinking, okay, if I want to actually, if all I really care about is the Hispanic Latino population, I don't need this. It's obviously just um, 100% minus Hispanic Latino population. So if I run that, I can get for each state the Hispanic population. Um, so that's just an example of kind of how, because your data comes in this tidy format, it allows you to really take what you get directly from tidy census and without doing any additional wrangling, be able to do things to it. Now, you've also, sorry, was there anything?
No, it's a perfect example because that really was one of the main motivations. What you just did is, what I see as the fun part of the data analysis. It is interesting to have a data set that you can go and explore and generate insights from. But as any data analyst knows, there's a lot of overhead that goes into that. I want to ask this question. I am a journalist and I want to write about Hispanic or Latino population by state, but
Mhm.
there are all of these other things that I have to do to even get to that point. And if we can automate away all of those more tedious tasks and really focus on the exploration of the data and kind of the insights generating process, that I think allows us to be more creative, and it allows us to frankly generate more interesting insights because we're spending less
Yeah.
time on the tedious stuff. And that was a
And
major
just to
motivation
show people kind of like
for
how
running the package.
amazing this process is, I could change that to county and the rest of my code will still run. And so I can see, for example, which are the counties that have the highest
Mhm.
Hispanic Latino populations. A bunch of counties in Puerto Rico, not surprisingly. Um, but then scroll down and see.
Right.
Okay, it looks like Starr County, Texas, aside from the Puerto Rico counties, is the one with the highest. And it's just amazing that you can change kind of
Yeah.
one little thing and rerun your code. Which, going back to your example of when you were doing click GIS stuff, we haven't even gotten to the mapping portion yet. But being able to rerun your code for, oh, now I want to do it by county is super
Right.
fast.
Right.
Um, so you also, I did this in a way where, we got our data in that long format, and then I used these two together to calculate the percentage. But you've also added an argument called
Yeah.
for summary variable. Explain what that is and how it works, and then I'll walk through the code here
Yes.
that uses it.
So this will be a familiar topic to uh, any of the data analysts listening, but count data can be very misleading if not appropriately contextualized. You can look at something and say, ask a question, what is the most Hispanic county in the US? Or what is the most Hispanic state in the US? And frankly, your answer to that question of what is the most whatever in the US is almost always going to be Los Angeles County, California, because it is so much bigger than just about any other county in the country. And that's because Los Angeles County has a huge population, especially when compared to a lot of other counties that are maybe proportionally more Hispanic, but just have much smaller populations. And so, what's important to do is normalize your data. And that's what, David, that's exactly what you just did when you divided the value by the sum of the value. But this normalization process is so important for analysts working with census data that I wanted to have an additional feature to make that easier because it's not necessarily easy out of the box. What census does with its tables is typically it has a parent child relationship between variables and tables. And the first row in each table is typically going to be your denominator because not every variable in the census or in the ACS is enumerated for the entire population. For example, educational attainment. Census tabulates that data on educational attainment for the population age 25 and up because it doesn't make sense to ask if a 12-year-old has a college degree. I mean, unless they are, some sort of very accelerated kid, we wouldn't anticipate that that would be true. And so you might say, well, look, this population is
Right.
relatively has lower levels of educational attainment. No, it's just because it's a bunch of middle schoolers. And so knowing the appropriate denominator is important. And so in this particular instance, though, when you're doing tabulations, let's say I pulled data on race ethnicity as we're doing here or on educational attainment. What the summary var option gives you, it allows you to specify a specific variable that you want to use as your denominator. And so you'll have all of the data for the numerator variables that you want to compare. But if they all share the same denominator, say white, Black, Hispanic, Asian, Native American, they all share the same denominator, which in this case is total population. You can have all your numerators in one column, your denominator in a second column. And so calculating group-wise percentages is as straightforward as
So let
dividing
me actually run
the
this.
numerator column by
I
the
put in
denominator
the
column.
summary
And then you can
var, which
compare
was
them
the
pretty readily.
P2001N, which is the total here, like you were talking about for that table, is the natural
Yeah.
summary variable. And so, too many. Let me
Yes.
run that again. So now I end up with value and summary value. So that summary value, I'm assuming, comes from this here.
Correct. Absolutely. So that's your denominator. That is your summary value that is the appropriate denominator for the numerator or numerators in the
Yeah,
value column information.
value divided by summary value. Let me just run that. And so you can see I actually end up with the exact same thing as
Mhm.
I did above. So Puerto Rico is 98.9%. And so, for example, if I
Yeah.
run this, oh wait, forgot that I was doing. Let me switch it back to state. You can see there's Puerto Rico 98.9%. So it's doing the exact same thing, but it's just allows you to do it in a more succinct way, which is handy, especially if you're doing this kind of thing over and over and over. So, cool. So let's talk briefly now
Absolutely.
about a couple things. Just I'll touch on this briefly because um, I think really clear. We've used decennial census data up to this point, but you can also use data from the ACS. And the really nice thing is
Yeah.
the syntax for working with ACS data is
Yes.
really similar to the syntax for working with decennial census data. So to be honest, I mostly use ACS data. I never, just because decennial census doesn't come out that much. I'm oftentimes working with people who want ACS. They want more up to date things. So
Right.
um, I know the arguments for
For
that
sure.
function, but it actually worked really well, with the get decennial function as well. So for example, if I want to get median age by state, which I guess this is one of the ones you have memorized, is that what you said?
It's one of the two. I
Okay.
use median age and median household income in most of my
Okay.
examples.
So we can see that Alabama um, has uh, the 39.2 is the. Now there's also an MOE. Can you talk about what that is?
Yeah. Sure. So, a couple of things about the ACS that users should be aware of. You'll notice in red the message that prints out that says getting data from the 2016 to 2025 year ACS. So, the American Community Survey comes in two flavors: the 1 year ACS, which comes out annually and represents a single year point in time, and the 5 year ACS, which is a rolling average over a 5 year period. And because the ACS is based on a sample, um, to get reasonably accurate estimates at small geographies, those ACS data need to be pooled over 5 years for small geographies. So 1 year ACS data, which you can get by putting in the argument survey equals ACS1.
Yep.
And so actually, David, go ahead and run that. You're going to get an error message. The that pulls from the 1 year ACS, and the 1 year ACS only returns data for geographies with populations 65,000 and greater, which is all states in the US, but not all of the counties. Now, due to data collection problems because of the COVID-19 pandemic, the Census Bureau actually didn't release the regular 2020 1 year ACS. They released instead a series of experimental estimates that are not on the API. And you can go and download those experimental estimates, but they have different variable IDs. They're in a different structure
Gotcha.
than all of the other ACS data. So I don't support them in tidycensus. There is a link that prints out with the error message here where you can go and download them yourself if you need them. So we can get ACS data back to 2005. And so 5 year ACS data, by contrast, you can get all the way down to the block group level for many variables. And so the default is survey equals ACS5. And so basically what you've pulled here for block group, you get an unknown unsupported geography hierarchy error. So there are, I want to say 240,000 block groups in the United States. The API does not return all of them at once. So if you want to grab block group level data, you'll need to specify a state. So if you were to, put in the argument state equals OR for Oregon, you will be able to pull down that data and it'll give you back median age for all of the block groups in Oregon. As you can see, when you get down to the block group level, which is typically going to be around 1,500 people, give or take, you'll have some
Yeah.
neighborhoods that are much older and some neighborhoods that are much younger. So getting back to your previous point, so that's the distinction between the 1 year and the 5 year ACS. You'll notice the default data structure of get ACS differs from get decennial. You get GeoID, name, and variable, but instead of a value column, you get an estimate and an MOE. And this is an opinionated design decision I made with tidycensus. Data, so the ACS includes estimates, which are not precise counts, but they're rather estimated characteristics of a given population, characterized by a margin of error, because these are not complete enumerations. They are inferred from a sample. And so that first block group in Baker County, Oregon, has an estimated median age of 59, with a margin of error around that estimate of 3.7. And so by default, census reports margins of error at a 90% confidence level. So you can kind of read that as we are 90% sure that the true value for median age of this block group is either is somewhere probably within about 55 to 63. We're 90% sure it's in there. You can kind of interpret it as that. And so ACS estimates are fantastic. They're the best data we have, but margins of error are not returned by default if you just make a call to the census API. You have to request estimates and margins of error separately. What tidycensus does is it sees the variable B01000001. It automatically fetches both the estimate and the margin of error for that variable, formats it, and gives you back both. And I've had people over the years say, well, I don't really want the MOE. Can I just get the data without it? And I say, no, I'm not going to let you do that.
Yep.
Because the estimates themselves need to be interpreted in the context of the margin of error, because you can even see, look at, let's see, the sixth block group in the table. It has, or even the third one is a better example. It has a margin of error of almost 18. So, you might say, well, can I be confident
Yep.
in these estimates? I think you need to treat them with, you know, an appropriate level of understanding that these are estimated characteristics.
I
You
will
need to
say it's disheartening, and I have to have difficult conversations with people that
yeah,
I work with to say, like, look, here's the data, but the margin of error is really huge, and you need to have you need to be really careful in how you interpret this because you know, there's just not a lot of certainty. Um,
yeah. There's a follow-up to that, though. One of the nice things about the way census data are
mhm,
organized, you could pull down at the block group level, look at it
right.
and say, I'm uncomfortable with the size of those margins of error. Go up to the census tract level, which is a little bit bigger.
The other nice thing, and I think this is what you were getting at when you said the reason that you wrote tidy census,
Yeah,
is you can also use it to, in addition to getting that demographic data, bring in geospatial data. So let me run this, and the one thing I did is this geometry equals true. And while it's running, why
yeah.
don't you talk about what adding geometry equals true does?
So the reason why I wrote tidy census was my general frustration with the kind of tedious process of making a map of census data and all of the data assembly that needed to be done. And what I wanted with this package was something where I could completely automate that process or at least automate it as best as possible. And so we mentioned earlier in the podcast, my first kind of real R package I wrote is a package called Tigris, which talks to the census FTP servers and brings in census shape files, which are geographic boundary files, and then loads them into R as what are called simple features objects, which is the main way that geographic data, or one of the main ways that geographic data are represented in R. So you can do GIS work. What geometry equals true does is it takes care of that entire process for you. So if I say geometry equals true and it defaults to false, but if you say geometry equals true, get ACS looks at the arguments that you've given it. Okay, state and year. It then goes and gets, using the Tigris package, state boundaries for 2020. If they need to be downloaded, it downloads them from the census website. It unzips the folder. It reads the shapefile into R. It formats it in an appropriate way for joining to the demographic data that the function has also retrieved from the census API. It computes the join for you, and then it gives you back what's called a simple features object, which is shown here. That is pre-joined geographic and demographic data. So you'll notice it's the same structure, but there's a new column called geometry. You can think of this as like playing connect the dots, but there's a whole lot of dots. And so it's a bunch of XY coordinate pairs that if you connect them in order are going to form the shape of each state.
So let's actually show folks, I actually have a separate chapter. I was actually talking with someone last week about mapping generally. So we don't need to, that was actually, I love that explanation, by the way. Connect the dots just with a whole bunch of dots. Um, that's such a good way to think about that geometry column. But so in other words, we don't need to get super into the geospatial stuff. But let just to show folks, actually, I'm gonna delete that line
Sure,
for now.
sure.
I'll add it in a second. Um, we can pipe that data in, and there is a geom, if folks aren't familiar,
Yeah,
geom-sf
that's a good
that
idea.
allows us, and I'll let you this too, really simple. The only aesthetic property I'm going to set is fill equals estimate. So in other words, folks or states with a higher median age will get darker, darker color. Let's see what that looks like. A lighter color, I should say. So amazing. So we've gotten that data, piped it directly into ggplot, and in what is that, 8 lines of code, have created a map. Now, of course, there are a few issues with this map, right?
Yeah.
First of all, the Hawaii, Alaska,
Right.
are and Puerto Rico's kind of here. Um, you know, they're not. It's not ideal. And when we were talking, when we were emailing before we got on here, my initial approach was to do this. I was going to do filter name does not equal Alaska. And this is, you could write this in a slightly more efficient way, but um, name does not equal Puerto Rico. So just to filter out those states slash territories. So I just get the contiguous lower 40. Now you said that that's fine, but you actually
Sure.
have another way of dealing with that. So the function is from the Tigers package. It's shift geometry. Before I run it, talk about what it does.
Yeah, so this is a long-standing problem in cartography for the United States, where you have one state that is absolutely massive, and if superimposed over the continental US would basically cover half of it, and that's Alaska. And it's compounded by the fact that the Aleutian Islands cross the 180-degree line of longitude. And so if that first map, you have the Aleutians stretching onto the
That.
right side of the map over by kind of far eastern Russia. And so um, that's an issue. Another issue is Hawaii is really far away and Puerto Rico is reasonably far away. And so a common thing that cartographers will do in a GIS context is create something called an inset map for Alaska, Hawaii, and Puerto Rico. And so what an inset map will be is for anyone who's worked with QGIS or ArcGIS, you set up 3 or 4 different maps or 3 or 4 different data views. You choose an appropriate, what's called a coordinate reference system. So a kind of way of projecting your data to 2D that's appropriate for each location. And then you create a map layout where you're plugging in the different views onto a map layout. Now, it's just something that is very, very commonly done in cartography of the US, and it's something that I always did. But this is something that is possible in R. It can be a little tedious. You can use, say, patchwork to do it, using ggplot, which can frankly, I mean, patchwork is, you know, I think it's a properly rated package. I would not say underrated, but it's just absolutely incredible for composing plots. But on the other hand, I mean, kind of wanted to make this a little bit quicker, and so um, originally, a few years back, I included some functionality that would shift, that basically use an alternative pre-made geometry. Um, and this is an old
Mhm.
argument in the package. It used Bob Rudis's kind of old, what is it called, the Albers USA package, and it used those geometries. And instead, if you asked for it, it would use those geometries instead of the tiger line geometries from Census. But about a year ago, I started getting some requests and I started thinking about how to make this a little bit more generalizable because those alternative geometries were problematic for a couple of reasons. One was counties actually change over time. Alaska gets new county equivalent areas all the time. And so I would have had to just keep that internal data set constantly updated, which was kept causing downstream issues. And the other thing is there wasn't any functionality to put on an overlay on that shifted map. So shift geometry is a generalizable way to handle this. What it does is you give it a data set of the United States and it is not 100% configurable, but it has 4 different layouts that you can choose from, uh, which is governed by the arguments preserve area, which is true or false, defaults to false. If true, Alaska will be really big. Um, and then position. And so you can choose position equals below, which is the default. or position equals outside, which will kind of put the different territories in reasonably appropriate geographic positions. And so this will, for any input data set of the US, it doesn't have to be from Tigris or Tidy Census, it will move the data for appropriate national mapping. And so now, by calling shift geometry, we move everything around. So this is using preserve area equals false. So we're shrinking Alaska quite a bit, and we're increasing the area of Puerto Rico and Hawaii, uh, in Puerto Rico's case, by quite a bit. So you can see it. And then we're moving them below the continental United States in a way that you can make a reasonable comparative map um,
Right.
of the different states. And so now you can see much better,
Yeah.
how Alaska, Hawaii, and Puerto Rico compare to the continental US. So there are a lot of kind of little fun little features in both Tigris and Tidy Census that do data manipulation like this. And so I encourage you to, if
Yeah.
users are interested in maybe
I
doing a little bit
see.
more, um,
Right.
you might consider taking a look. So that there you go, preserve area equals true. Alaska is
Hmm.
is massive, and some cartographers argue that, frankly, this
Right.
is always how things should be, um, because Alaska is actually that big, and it should be represented as such.
I'm inclined towards preserve area equals false, the default as well. Um, it just it's a much more elegant solution, of course, than what I did, which was just to remove those, and it allows them to be seen in a really easy way. Um, and I just added, this was up here before. What was I use? I had just added a different color palette just because I find the default a little hard to read, but this just allows us to more easily see, which states are older and which states
Sure.
are younger, have a younger median average. And so the nice thing is, again, because we're just putting this straight in from get ACS using shift geometry, then from Tigris, and then piping it straight into ggplot, we're able to, do everything else that we do with ggplot, like ch- choose a different fill scale to make our maps look and hopefully communicate effectively. Um, Great. Is there anything else on the mapping you think would be useful to talk about?
Honestly, um, again, being able to do this quickly, it was my major motivation for writing the package. And
Yeah.
what this opens up there is so many different kind of maps you can make. So um, I have a book coming out. It's called Analyzing US Census Data, Methods, Maps, and Models in R. CRC Press this fall. You can pre-order it today.
Yeah.
And it's available also to read for free online. So, it'd be great if y'all go pick up a copy because, that helps me maintain the free version, but it is free. And chapter 6, which incidentally is the most visited chapter of the book by far, is all about mapping census data. So, you can dig in there. This is a Coro Plus map, so a shaded map, which is one of the most common census maps that you'll make. But you can learn in here how to make all sorts of other types of maps. Dot density maps, which I quite like, graduated symbol maps, interactive maps. There are a lot of different options that you can explore. And, frankly, that's what often excites me the most when I see people using Tidy Census, because this is the creative part of analyzing and visualizing data. And if Tidy Census help people get to that creative aspect of their data work faster, then there's so many interesting things that can be done with census data because y- they're so applicable to a wide range of different fields. And I will say as well, because David, you all have listeners from all over the world who might be saying, this is so we've got, the US Census data. I'm interested in my country or I'm interested in a different country. So I encourage you to check out my book, chapter 12, which talks about international census data and shows some resources for census data around the world. And these different methods that we've been talking about, there are a few other packages that are really, really good that can
Cool.
apply similar
Yeah.
types of.
I'm based in the US.
So
I know, a lot of folks are, and I use US Census Bureau data a lot, but the overall idea that you can use R as a way to access data through an API and pull it in a way that's so much more efficient than the manual alternatives, that applies way beyond this specific tidy census example. And the nice thing about R being open source is people have made packages to allow you to access data from the Kenyan census or, any other source. I've been pretty shocked actually at how many, the wide variety of packages that can help you do that.
absolutely.
Um, Super. Well, this has been really, really helpful. I will definitely include a link to your book. Um, where else can people find more information about you if they're interested in learning more about your work?
So I'm on the web at walker-data.com. That's my consultancy website. And so if any listeners are needing help with any of this stuff, feel free to send me a note. I work with everyone from large companies to individuals. And you can follow me on Twitter. I'm off and on Twitter in terms of how active I am, but that is often where I do share new features that I'm developing. I also have a mailing list that you can join. The link to that is on the Tidy Census documentation. And check out my GitHub as well. So that's a good place to stay on top of new features that are coming through. Tigers and Tidy Census are the packages that people are most familiar with, but I have a few other packages too that you might find useful. So check out my GitHub. I'm
Cool.
reasonably active over there as well. But yeah, drop me a line if anyone wants to chat further. I'm at kyle@walker-data.com, and I love hearing from people.
Great. Well, thanks again, Kyle. I really appreciate you taking the time to share all of this with us.
Yeah, of course. Thanks, David. This is a lot of fun.